Hi Year 11. Today what we're doing is looking at square root relations. So we're going to examine the relationship between the graph of y equals fx and the graphs of y squared equals fx and y equals the square root of fx. And hence we're going to sketch the graphs. So the relation y squared equals fx is not a function. It can be broken into two separate functions, y equals plus or minus the square root of fx, by taking the square of both sides, the square root of both sides. This then gives us the two functions, y equals the square root of fx and y equals the negative square root of fx. Each of these are functions by themselves, but together they are a relation. So for the function fx equals x minus 2, we want to sketch the graph of y equals fx. What we have is y squared equals fx, where our fx function is our x minus 2. So this means that we have y squared equals x minus 2, and we'll have y equals plus or minus the square root of x minus 2. Now, what we want to do is we want to look at our domain. So with our domain, what we have is it is what our x values are, or what our x values can be. And so what we'll have is x minus 2 has to be greater than or equal to 0, because we can't have a negative square root, a negative number under our square root. Otherwise, this is a complex number, and that is extension 2. Or values less than 0. Okay, so what this means is that for our domain, we have x is going to be greater than or equal to 2 once we plus the 2 to both sides. This means that therefore our domain is going to be from 2 to infinity. Yes, Murphy. So now what we're going to do is we are going to sketch both our functions. We're going to sketch our positive version and our negative version. So in one color, we are going to sketch y equals the positive square root of x minus 2. And in a different color, we are going to sketch y equals negative the square root of x minus 2. So what we can do is we can use a table of values to sketch our first graph. So we're going to use a table of values to get x, and y is equal to the square root of x minus 2. Now our domain is from 2 onwards, so our first x value is going to be 2, then 3, 4, and then I'm going to do 6 and 11. So what we have is that the square root of 2 minus 2 is 0. So I'm going to start at 2, 0. Now the square root of 3 minus 2 is 1. So at 3, it will be at 1. The square root of 4 minus 2 is at root 2, or 1.4. And the square root of 6 minus 2 is when we get our value of 4, square root of 4, which is just 2. And our square root of 11 minus 2 is 3. So at 11, we are at 3. What we then want to do is we want to sketch by connecting our points, like so. And we have our y equals the square root of x minus 2. Now, we were asked to sketch both our functions. So what we need to do is to sketch our y equals negative root x, we need to remember that y equals negative f of x is reflected, or is our function reflected about the x-axis. So that means for all of our y values, we're going to change the sign. So the sign of our y values change. So that means we'll still have our point 2, 0, but then at my point 3, 1, it will become 3 minus 1. At 6, 2, it will become 6 minus 2. And at 11, 3, it will become 11 minus 3. And what you'll see with our square root relation is it becomes a sideways parabola. So this, Murphy, is our graph y squared equals fx. And our red, thank you, Murphy, is y equals negative root x minus 2. So as you can see from the example, the two separate functions are symmetrical about the x-axis. This is always the case for graphs of this type. Turning over your page. So we want to sketch the graph of y equals the square root of fx, given fx equals x squared plus x minus 2. So what we will have is that y equals the square root of fx is the same as y equals the square root of x squared plus x minus 2. Now it's important to note that all we want is the positive version. What we're going to do to get this is on our first axis, we are going to sketch the graph of y equals fx to see what happens and do a bit of an investigation. So in order to sketch y equals fx, what we have is it is equal to x squared plus x minus 2, and we need our x-intercept. To get our x-intercept, we let y equal 0. Yes, we do, Murphy. And so, we have 0 equals x squared plus x minus 2, which factorizes to get x plus 2, x minus 1. And so therefore our x-intercepts, Murphy, is equal to negative 2, 1. Our y-intercept, what we have to do is we let x equal 0. So we get y equals 0 squared plus 0 minus 2. Y equals negative 2. So therefore our y-intercept is at negative 2. Now this function is a parabola. So I'm hoping you're yelling out, you need to find the axis of symmetry next. And if you are, that would be correct. So our axis of symmetry is found using the formula x equals minus b over 2a, which is x equals minus 1 over 2 lots of 1, which is just equal to negative a half. So therefore we have x equals negative a half. Probably don't need to write that there. And then we need to find our vertex. So our y coordinate at this point is when we substitute in negative a half into our original function. So negative a half squared plus negative a half minus 2 gets us a value of negative 2 1/4. So therefore our vertex is at the point negative a half, negative 2 1/4. Okay, so what we have is if we sketch this function, we need axes, gosh, sorry, 1, 2, 3. Okay, so should have prepared this earlier, Murphy. Oh, yes, I know. Silly. Alrighty, sorry about that. Okay, so we know our x-intercept is at -2, 1. Our y-intercept is at -2. We have our vertex is at -0.5, -1/4, which is roughly there. So at -1, it's at -2. And let's just quickly check what is happening at -3. Thank you, Murphy. -2. It is -3. It is at 4. And so at 2, it must be at 4. Murphy, shh. I'm trying to teach. Okay, so then we can draw our parabola. Now, because we want the positive version of our parabola, what we want for our y equals our square root of our function is depending on what is underneath our square root symbol. So for our y equals square root of fx, fx has to be greater than or equal to 0. So that's for our domain. So for our domain, what we have is x squared plus x minus 2 is greater than or equal to 0. So at our x-intercept of x plus 2, x minus 1 is greater than or equal to 0 when we factorize. And so then we get that x is going to be less than or equal to -2 and x is greater than or equal to 1. And so what this is saying is for our original function, so our original function here, we want only what is above our x-axis. What is above our function, what is above y is greater than or equal to 0. So what that means, oops, gosh, I'm having a shocker, is that we want f of x is greater than or equal to 0. So all we want for our f of x to be greater than or equal to 0 is it's these values here, which is when x is less than or equal to -2, so going in this direction, and when x is greater than or equal to 1. So all we are going to be drawing for this is where for our domain of x is less than or equal to -2. So that will look like a domain of negative infinity to -2 and 1 to infinity. Okay, so we need some key points. We obviously have our x-intercepts of -2 and 1, but let's see what happens underneath our square root symbol when we have x equaling 2. When we do that, we get 2. Let's see what happens at 3. Or we get 3.1, 3.16. What happens at 4? We get 4.2. And at 5, we get 5.29. So it looks a little something like this. Okay, let's see what's happening on the other side of our graph. So at -3, we have that it's at 2. At -4, it is at 3.16. And at -5, it should be at 4.24. As you can see, we have that our graph reflects in our axis of symmetry, and we are only looking at what is above our function. Oh, oops, I forgot that there's a table of value here. I'll quickly fill it in for you. Just to 1 decimal place. Asymptote does not exist. 0, 2, 3.2, 4.2, 5.3. There we go. Okay, so we know what part of our domain we want, and then we just do it as a table of values. Alrighty, turning over the page again, we want to sketch the graph of y squared equals fx if fx is equal to x bracket x minus 1, x minus 2. So what we have is y squared equals fx, where y squared equals our function of x, lots of x minus 1, x minus 2, and we have y equals plus or minus, because we're taking the square root of both sides, the square root of x, lots of x minus 1, x minus 2. So what we want to do first is we want to sketch our original function on our first graph, which is x lots of x minus 1, x minus 2. And this is a polynomial that is cubic, and we can see that our x-intercept is equal to 0, 1, and 2. Our y-intercept is equal to 0, and we have that our degree is equal to 3, which means it's an odd function, and we have our positive leading coefficient, meaning that we will start down the bottom left and end up the top right for this function. Okay, again, I have not put this on here. I know, Murphy. Sorry about all the interruptions during this little lesson. Hopefully they have been okay. Alrighty, so we are drawing our function. We have intercepts at 0, 1, and 2. We are starting down the bottom somewhere here. We are going up, down, and then back up. So that is a rough sketch of our function y equals fx. Now, for y equals fx, remember, we have to have our domain of fx is to be greater than or equal to 0. And so what we have is x lots of x minus 1, x minus 2 is greater than or equal to 0. And so we are looking at, on our original function, where is fx greater than or equal to 0. So it is greater than or equal to 0 between 0 and 1 and from 2 to infinity. So that means, that our domain, we have that it's between 0 is less than or equal, it's between 0 and 1, and it is that x is greater than or equal to 2. So therefore, yes, we're nearly finished. Our domain is going to be including 0 and 1. Oh my gosh, that's such a bad bracket. Oh yes. Sorry, give me 2 seconds. Oh, there we go. Between 0 and 1 and 2 to infinity. Alrighty, so that means we only want these sections of our graph. What we can do is a little table of values. Yes, I thought since I did a table of values for the last one, I would be doing a table of values for this one. So we want to have the square root of x, lots of x minus 1, x minus 2. So let's put that into our calculator. We are starting with good old 0. When we substitute in 0, we get 0. Next, we're going to do a quarter. 1 on 4, 4, 1 on 4, oops, delete, yes, 1, oh, far out, did it again, 1 on 4, There we go, I got it, that was a bit tricky. So when we do that, we get 0.57. All right, when we change that to 1/2, we get 0.61. When we change that to 3/4, we get 0.48. When we substitute in 1, we get 0. When we substitute in 2, we get 0. Now, what is happening between 1 and 2 is that our graph is below, our original graph of fx is below our x-axis, so we actually don't want what's happening between 1 and 2. If we were to substitute in 1.5, we would actually get an error a math error, because we will have a negative underneath our square root symbol, and like we have discussed, we cannot have a negative underneath our square root symbol. If you don't believe me, you can try it out. When we substitute in 3, we get 2.45. Then when we substitute in 4, we get 4.9. And when we substitute in 5, we get 7.75. So to sketch just the positive version, y equals the positive square root of fx, we now have some key points, 0, which are our intercepts. We have that it goes up to 0.6. Well, probably a bit lower than that since that's at 1. We have that at 3, it is at 2.45. At 4, it's at 4.9. And at 6, it is at 7.75. So we have a little hump here. Ooh, that's not very good. A little hump between 0 and 1, and then almost a straight line between 2 to infinity, and that is the graph of y equals the square root of fx. Oh yes, Murphy, one more graph to go, I know. Our last one is we actually wanted to sketch the graph of y squared equals the fx. So when we have y squared equals fx, that is when we have y equals plus or minus the square root of fx. So we want what's above our axis that we just drew to 2.45, 4 is at 4.9, and 6 is at 7.75, like so. Okay, but we also want the reflection about our x-axis, so what is going on underneath. So we have a little circle going on. We have at 3, or at 2 it's at 0, at 3 it's at negative 2.45, at 4 it's at negative 4.9, and at 6 it is at negative 7.75. And so when, oh no, that's at 5. No wonder that looks a little bit sketchy. I thought it was more meant to be a straight line. I'm hoping you picked that up and you're like, what is she doing? Okay. So like so. Alrighty. Well, I'll just quickly fix up these graphs for you. But hopefully you picked that up. Because we're at 5, we're at 7.5. Okay, so that is then the graph y squared equals f of x. Now, what you guys will be completing is exercise 708, question 1 to 2, ACE, so every second letter. Sorry for all of the little interruptions from Murphy. You wouldn't believe it. He's decided to go and lie on the lounge now and not be a distraction. Good luck with getting the exercise done. It is homework, and I will see you tomorrow.